Hello.
Hello, ma'am.
Yeah, ma'am, we'll start the session, ma'am.
Okay.
Participants are yet to join.
Okay.
Hello. Hello. Am I audible to everyone? Yeah. Good morning, everyone. We'll be starting the session in a few seconds because there are more number of participants joining.
That labs. No. That lab.
Hello. Yes. The participants count has reached to 63. Let us start the session. Yeah. Thank you. Yeah. Good morning, one and all. I'm Dr. Tripti, Associate Professor from Department of AI. Will be moderating today's forenoon session. On behalf of AI Department, I take the privilege to welcome all the participants and resource person, Dr. Alka Mohan ma'am, for joining the Day 2 forenoon session of the Faculty Development Program on Deep Learning and its cutting-edge applications organized by Artificial Intelligence Department at Anurag University. Ladies and gentlemen, it's my honor to introduce our esteemed resource person for the forenoon session, Dr. Alka ma'am. Welcome, ma'am, for the session.
Thank you.
Yeah. Dr. Alka Mohan ma'am, as an impressive professional journey marked by her dedication to academia and research. She has served as an assistant professor at the prestigious institutions across India, including the Indian Institute of Information Technology, Tiruchirappalli, VIT Vellore, Geetham University, Bangalore, and IHRD College of Engineering, Kerala. Dr. Alka was awarded PhD in Computer Science from National Institute of Technology, Karnataka in the year 2022. She has also earned a master's degree in Computer Science Engineering and secured fourth rank in it. And she's also qualified UGC NET in 2014. Dr. Alka's research contributions are significant in advancing hyperspectral imaging and related technologies. Her notable projects are GIS-based route optimization for solid waste management in Tiruchirappalli city and AI-driven hyperspectral image analysis for GIS applications. She has made a significant contribute to academic literature with research publications in reputed journals, to name a few: hybrid CNN-based hyperspectral image classification using multi-scale spatiospectral features published in Infrared Physics and Technology. V302 hybrid deep learning model for hyperspectral image classification using Vanilla 3D and Octave 2D convolution, published in J Real-Time Image Proceedings. Temporal convolution network based rice crop yield prediction using multispectral satellite data, published in Infrared Physics and Technology. She's also been a reviewer for peer-reviewed journals, including International Journal of Remote Sensing and IEEE Geoscience and Remote Sensing Letters. Moreover, Dr. Alka has taken on various administrative responsibilities, including Assistant Registrar in charge, ISRO Outreach Program Coordinator, and Nodal Officer for the Ministry of Education, Indian Approved ERP System Samarat, and participated in pedagogical training at IIT Madras. Dr. Alka Mohan, wealth of experience, academic achievements, and contributions to research make her a valuable resource person for today's session. Ma'am, we look forward to gain insights from her expertise on the topic for today's session, role of AI in precision agriculture. Please join, and I request all the participants to join to welcome Dr. Alka Ma'am, Assistant Professor, School of CSE, IIT Tiruchi, to take over the session. Ma'am, the session is over to you.
Thank you, Anurag University and the Department of AI for giving me an opportunity, and especially for the Professor Victor Daniel for calling me for the particular session. And before going to the actual content on the section, I'll be just give a glance on what is going on the current AI. I'll share my screen. Is it visible, ma'am?
Yes, ma'am. I'm giving the co-host privileges to you, ma'am. One second. Yes, ma'am.
Thank you. Before going to the today's section, actually the section is mainly based on the role of AI in precision agriculture. What is precision agriculture? How it will be working for AI? Before going to all of this, I'll be just introducing this website and some number of based on the number of participants while find. I know more than 50% of already known to this website, and some of few of them will not be that much aware of this website. This is the government website. You'll be hearing that indiaai.gov.in. That is the what is the vision of India for the using the AI technology. Inside that, you'll be going for different technologies or different areas of research. If you are doing any research, all our faculty members, I feel so, and some of them will be already having PhD, and some of them will be doing PhD. Some of them will be having students under you, and if you'll be going for some research, well, the main focus should be on the country is needed. That is, what is India's vision on AI? Everyone is speaking regarding AI. We have to work on this one. This area AI should be there. That area AI should be there. We'll be going for the deep learning. The deep learning textbook itself, it is written that it is not a hammer for all the nails. where you have to use this AI, what is the inline project associated with our country. These are all we have to know. For that, we'll be just introducing this India AI website. Everyone can go through the website. We'll be having mainly 4 sectors. We'll be going through the sectors. You will be having healthcare sector, financial technology sector, agricultural sector, and cyber security. Your all project or papers or research work or that you are doing, or your student doing the research, or your along with your colleagues, you will be having a research group. It should be in line with the India's vision. That is my prior request to all of the research community. Either you can work on any one of the sector. Your research should be other than a paper. It should be a product that should be helpful to the layman. That should be your motto. You can focus on any one of this main sector. Based on that, you start your research. That is a humble request from my side. Either you can focus on the healthcare, or you can focus on the financial technology, or you can go for the agricultural technology, or you'll be going for the cyber security thing. We have here today's topic will be mainly focused on the agricultural technology. You can go through the agricultural technology. You will be came to know so many things are working in AI based on this agricultural technology. AI tool for banana farmers, protect their crop, optimize irrigation, empowering intelligent insight, quality assurance for the agricultural product, farm management, livestock management, weather forecasting for the crops, and sensor for making the farmer smarter. These are all the main things that is already doing, or will be research is going on this area. I did my PhD in the related area for the agricultural technology. Therefore, I took this as an insight for the current researcher, or those who are continuing research, or those who are starting research. It should be an insight like that. I'll be introducing some 2 problems that I addressed in my research work, or I am continuing in my research work. Along with that, we will start some future insights also. Like that, I design my session. They'll be going to the I think you're all visible to that PowerPoint presentation. Now we'll be going to the actual sectional part for the today's topic, that is role of AI in precision agriculture. It's visible, ma'am. It's everything fine, and audio, all these things.
They're audible. It's completely fine. Your PPT is being displayed.
Okay, thank you so much. Now we'll be going to the actual topic or the today's research area, that is the precision agriculture. Will be from the picture itself you came to know so many drones are will be flying around for the farmland, and the farmer is doing some, will be using some tab or some mobile or something like that. He will be searching for all the items, or will be finding some insight from that one. Based on that, will be doing so many things. That will be the precision agriculture itself. Will be going for the agriculture. Precision agricultural part will be the science that is used to improve in the crop yield and assisting management decision using high technology sensors and analysis tools. In general, we can say that precision agriculture is using some decision, you'll be creating some decision support system with the help of artificial intelligence, or with the help of any technology, and you should have to manage your crop, or manage your agriculture, or manage your yield. That is the main idea behind this precision agriculture. You can use the smartphone, or you can use drone, you can use some sensors, or you can use some other stations or irrigation system, or you can use some UAV, unmanned aerial vehicles you can use. From that, you will be collecting the data. Based on that, you will be finding some insight. Using that insight, you will be managing your system. That is the main motto of the precision agriculture things. We will be dividing into 3 components. The first component is the information, that you have to gather the information from the farmland. It may be the soil condition, it may be the weather condition, or crop area, or agricultural things, and everything. For that, you have to use some set of sensors, or drones, or satellite images, or whatever it is. You have to take the information, and you have to find the actionable insight. The data will be converting to information, if you'll be converting that into insight, that you already know. From then, using that insight, you will be applying that insight on a technology, and you will be making some decisions, or you have to go for the management things. Going for the management things, there you will be using some softwares, or you will be developing a software, or you will be developing a new model, or you will be optimizing your resources. These are all the three components associated with the information management system based on the precision agriculture. This is the general thing that we have to use. You'll be having different questions in mind. Why we have to use all this information, whether all the information are valid, or which are all the informations are valid for a particular project, or which from where we will be getting the insight, which type of algorithm we will be using, how we can find the insight, how we can go for the decision. These are all the questions coming to the picture of a research point of view. There you will be applying this AI technique, machine learning techniques, deep learning techniques based on your data. You will be applying different technology, and you will be finding some management things, the automatic irrigation system, automatic that and the fertilizer applying system, or will be weather, be similar to that of weather, based on weather forecasting. You have to do some insight. These are all coming to the picture of the management case. Is the main idea behind the precision agriculture. You are using technology along with the some management things and the data, finding insight, convert that into decisions, and you will be using for the why we will be more focusing on agricultural part. The main decision we focused on agricultural part. All other part are important, equally important. Healthcare is equally important. Financial technology is equally important. Security, cyber security is equally important. But we'll be thinking about the day-to-day life. Agriculture is somewhat important, more important in the, because it's related to my area. Maybe I can say that that is somewhat important. Maybe for based on your things, it will be maybe security will be important. But the idea behind this going for the precision agriculture, or the India AI vision focus more on the precision agriculture, is because WHO already suggested one thing. The main problem arising in the current millennial part, or the current scenario, is the food security. Food security is the main issue, that you have to achieve the food security for the entire population in the world. For that, the day-to-day, that climatic conditions are different, the varying. Previously will be in this time. Normally, I am from Kerala. What I may say, I'll be connecting with some example. Normally, it'll be going the school opening time, June, July, that time. Every year, that time there will be rain. The rain. Therefore, the advertisement in the TV or the any advertising media mainly focusing on the umbrella advertisement. That was the common practice that we followed, or from the school day onwards we will be looking for that, what new things they will be adding this umbrella. First time they will add some whistle, they will be adding some light, all these things will be coming to the picture. Now after the vacation time will be from April and May. That will be the vacation time for the Kerala. Then will be starting from April to May, mid of the May, the weather will be changed to the rainy season. That was the condition. Previously in Kerala, at least mostly, if will be considering 100 houses, at least 1 or 2 houses having AC, air condition. That is that type of, or it will be having that much costlier thing. Now you'll be going through the advertisement in the TV or the social media, you will be finding that if you pay 1 rupee itself, Kerala, you will be getting AC. And later EMI onwards you can. Now all the companies, they will be focusing on AC advertisement. Why? It's because it's the weather change is going like that. Previously you can manage the, even though it is a summer vacation, you can manage the weather. You can manage the weather from April and May. The kids will be in home because of summer vacation, but you can manage the weather. Now the idea is you can't manage the weather. Every home, if you'll be considering 100 homes in a particular area, everyone is started buying the AC. The sellers started selling the AC. Therefore, the climate is diverging like anything. It will be going in different direction. For you should give some insight to the farmers before going to the divergence part, or before going to this type of situation. You have to give some information to the farmers, the layman, that the climate is going to this abrupt condition. Your crop can't manage this one. You have to do this decision. You have to manage your crop like that. that, or you have to use some other crop material. These are all coming to the picture. Then only you can achieve the food security for the entire world. That is the main motto or the main thing that will be mainly focusing on AI vision in the agricultural field. Then will be coming to the picture for the agricultural field. You have to use the whatever the technology that is already available, you have to use that for the management thing. That is mainly very important for the AI vision. I'll be going for this application. You have different application. I'll be just listing out some of the application. The yield prediction is an application, early prediction of irrigation system, automatic irrigation system, soil monitoring. Based on that, you have to use the which type of fertilizers you have to use for a particular crop, and detecting the diseases, early detection of the diseases. Based on that, you have to use the pesticide. Other than this crop or crop related things, the agricultural application mainly focusing on the livestock also. Either it will be cattle field or that type of livestock also, it will be their health you can monitor using some of the images or some of the sensors. And the pesticide application, weeding and harvesting, and the sorting the harvesting product, whether the whatever you're harvesting that will be good or bad, you can use some AI technique to harvest this one or to sort the harvesting item. And the surveillance, security, all these things come into the security. Now in the agricultural technology, now people are started using blockchain technology for the agricultural security part. That means I'll be giving an example inside for a project that will be started your project like that. You'll be having some crop, you harvested the crop, and it will be going from the farmer side to middleman, then it will be going to the large godown, then it will be going to the corresponding supermarket, then supermarket to the next level customer. Like that, the live track should be there. In the track where the people are using some pesticides or some unwanted things, that and all you have to be focused, and where it will be happen, and what are the information associated with this one. This information cannot be changed from where it is cultivated, which through which path it is going on. All these things you have to give some information. That information cannot be altered. For that you will be using, now people have started using this blockchain technology in the security in case of agricultural products. That is also another application area. These are all the mainly discussing part regarding the agricultural training or the precision agriculture. Now I'm going to my work. First, I'll give some glance of what I did in my research work for the precision agriculture, or what type of product I created for my research, and what I am continually using. My project or the research work was mainly focusing on the machine learning based crop yield prediction. Prediction was my motto. My motto was prediction. Before going to the prediction, if I'll be started this work, my idea is that the prediction, what are the things you needed? Predicting the yield, you need some parameters. The parameter may be your that parameter that will be climatic parameter, and the next previous year yield you will be having. And based on that, I can go for the prediction. That is normally will be discussing in your class. You will be having the faculties will be those who are taking the AI or the machine learning subject. They will be go for some regression analysis. Will be having a number of features. Features may be temperature, climatic condition, that will be what is the rainfall rate, what is the wind rate, and how much fertilizer you are using. These are all the n number of features. Based on that features, you can predict the data, you can predict the yield. That was the common technique that will be used. That is not up to the mark of a research. What you can go for the extra. Then we'll be focusing on the headline once again. Machine learning based crop yield prediction using spectral images. Therefore, image processing come into the picture. Other than whatever the data what we are using here, we'll be going for some image analysis also. Which type of images you are need for this type of project, or the crop yield prediction, whether you need a project, need an image, that will be a question. What type of image will be better for this type with this crop yield prediction? That is another question. All the images, simply you will be using a colored image, whether it will be giving a very good result. What is your motto of using the spectral images or the images in the yield prediction? Why you have to go for that much high data? whether you will be going for the big data analysis, what is the need of this big data analysis. These are all coming to the mind. How you can handle this one, what are the things you have to collect from the images, what image processing techniques you have to use. These are all coming to the picture. Therefore, we'll be just focusing on our focus mainly on multispectral and hyperspectral images. This remote sensing images we mainly focused. Why we are mainly focusing on remote sensing images? That was the question. You will be considering, suppose you have to predict the yield for a particular farm. You will be cultivating some wheat or rice or any other vegetable thing. You can consider a small area and you can cultivate the data, cultivate the crop in that area. You will be using some sensors. You will be collecting the information. What is the soil condition? What is the rainfall rate, what is the irrigation rate, what is the water density, all these things you are collecting using some sensors, and you will be finding the result, the yield. Okay, using this one, it is you may be considering for a 1 cent project or 100 or 20 cent or 30 cent project, and this small area you will be considering. Then you have to apply this for a large area. The cultivation land may be 1 acre, 2 acre, hectares or something like that. Normally, previously what we'll be doing, we will be taking a small area, we will use the cultivation or normal agricultural university, you'll be going for the agricultural university. You visit the agricultural university, you will be finding that they will be introducing new crop variety. They will cultivate the crop in their farmland itself, small area. Then they will be considering this, what is the yield estimation. Based on that, they will be giving the result that this type of crop will be better. Then you will be saying that if this condition, this crop will be better, you can go for the large area cultivation. That is, some interpolation or some extrapolation will be happening, whether it will work for the entire field or whether we will be having some difference on that. For that case, we'll be focusing on if you are using a remote sensing image or the hyperspectral image or the spectral image, then it will be better. That is, using the spectral image, you can cover a large area. We'll be going for the remote sensing image. You can cover the large area. From the large, other than a single 1 cent or 10 cent or 20 cent project, you can consider a full hectare, 1 hectare or 2 hectare or 100 acres of land. You can collect the data from the 100 acres of land very easily using remote sensing data. You no need of any manpower. You can use the remote sensing sensors and you can collect the data. That was on the next level of this project. Okay, I have to use the images for this analysis. This type of remote sensing images I will be using for the project. From the spectral image analysis itself, you'll be finding that will be RGB color images. You will be having RG and B. Multispectral images, you will be having some infrared, near infrared, far infrared, microwave. These are all the information will be available. Different levels. RGB color images, you will be having 3 bands. Multispectral images, that is more than 3 spectrum, other than RG and B. Different other spectrums also, maximum up to 20 spectrum levels will be there for the multispectral images. 20 wavelength factors will be there. Then using that, you can get the intensity value for red. This will be the intensity. Blue, this will be the intensity value. Green, this will be the intensity. Light green, this will be the intensity. Like that, you will be getting the multispectral images. But my idea is that we have to go for the hyperspectral images. Hyperplane hyperplane means more than 2 levels. Similarly, more than 20 spectrals are there, then you'll be going for the hyperspectral images. That is the idea behind this one. You'll be considering these hyperspectral images. If you are be plotting the intensity map on this one, you came to know that intensity map is a continuous map. Will be a contiguous map that will be better for analysis of the data. This is the main idea behind the spectral images. In the hyperspectral images, you will be having more than hundreds of band other than the multispectral data. Then why we will be going for this hyperspectral images? Why we can't use the multispectral or RGB data? For that, we discussing this is a single band image, multispectral images, more than 10 to 20 number of bands will be there. Hyperspectral images, hundreds of bands will be there. That is, they look like a 3D cube. Here, single band image, in multispectral, something similar to an RGB color image, 3 bands will be there. This is looking like a 3D cube. Then the term spectral signature come into the picture. That means if you'll be having any item in your earth surface, suppose it will be a rock or it will be a plant or different type of plant. It may be the plant may be either a paddy or plant may be any vegetable plant or plant may be any that a wheat plant or any big tree or whatever it is. Each item in the earth having a spectral signature. A map will be there for each of the intensity values, the wavelength value. Suppose you'll be giving a wavelength 200 nanometer wavelength you are hitting on the earth surface. Suppose rock is the surface, then it having a reflectance value. That won't be similar to that of you will be hitting the same 200 band in some other object, that may be some tree, that will be different. The reflectance value will be different. Therefore, spectral signature is actually the will be something similar to that of your thumb impression. Every object in the earth surface have its own spectral signature that won't be similar to that of any other object. That is, if you are considering a paddy plant or the rice plant, that spectral signature is entirely different from if you are looking for a wheat plant. Both that leaves are looking similar, but the spectral signature have a difference that will be looking like your uniqueness, thumb impression, similar to thumb impression, each one having a different spectral signature. Therefore, you need the spectral signature idea for the crop-yield prediction. Why? How we will be using this for crop-yield prediction? You will be considering your remote sensing image. Image is a large, you will be covering in a large area. Large area you will be covering, you will be focusing on some paddy land. In the paddy land itself, there may be some other shrubs will be there, some other trees will be there. How we can differentiate this from the other? That is a big question. For that, you can clearly identify in each pixel what will be the corresponding class. That may be a paddy, that may be any other shrub, or that may be wheat. Like that, you can clearly identify from the spectral image. Therefore, the segmentation or the classification of the cropland is very much important in the case of you have to predict the yield. That may be generally, if you are predicting the yield, you'll be considering a cropland. They may contain so many other type of shrubs are there. You have to discriminate the shrub from whatever the shrub you are focusing. Maybe you are focusing on rice, you are focusing on wheat, or you are focusing on tomato, or you are focusing on any other vegetable. You should have to discriminate it from other. Therefore, you need some spectral signature value. You need some segmentation or the classification from the large covered remote sensing area. That is very much important for this. For that, we focused on the hyperspectral images. If you are looking at the hyperspectral images itself, you will be finding that there will be number of bands will be high, more than 200 or 300 bands. Then one question came into the picture, whether all these bands are made for yield prediction. Some of the band is actually somewhat similar to the other band. There will not be any discrimination between them. Therefore, we'll be focusing on the reduction in the image itself. That will be dimension should be reduced, number of bands should be reduced. That is the main motto. Therefore, the objective of our work is completely divided. You will be only focusing on the spectral images. That will be going for the, you have to find the optimal band. Then you will be going for the crop area discrimination, discriminating the crop area. Then you will be going for the machine learning based prediction. These are all the three objectives we'll be focusing on: remote sensing based image analysis and remote sensing for the yield prediction. The first one I will not be discussing so detail, but it will be the second one, the area discrimination. This is the proposed work will be focused on the hyperspectral images. We designed a deep learning model. The image itself was a 3D image. The three-dimensional image will be mainly focusing on the three-dimensional convolution neural network. We designed a CNN architecture, multi-scale CNN architecture, that based on that we will be discriminating the data or discriminating the crop area. This was the first work we put forward for this one. That is in the input images, you have to go for the dimensionality reduction. That was the first objective. Then the second objective, you have to go for the classification or the segmentation. The classification or segmentation mainly focusing on you have to discriminate the scrub in the crop area. Each shrub you have to discriminate. This is the work you can focus on this. I think we'll be sharing the presentation. This is the paper we published in infrared. So this is the most cited paper in this area. We'll be using the hybrid CNN based hyperspectral image classification. This was the architecture. I am not going to that much detail of the architectural things and all. Be just giving a glance which are all the area you can focus on your research. This is the picture that will be the model we designed for the image classification or the segmentation part for the different type of crops. Then the next one is, okay, if you find which each pixel, which one is the crop or what is the crop, whether it will be the crop will be a shrub or any other weed or whatever it is we created. Then we'll be focusing on our main part, that is your crop yield prediction. Yield prediction itself will be used a TCN, temporal convolution neural network. That is the advantage of TCN is you have to predict the crop. Suppose you will be considering a rice plant, the rice crop. It will be maybe a 19 to 20 week process from the sowing state to the harvesting state. 20 weeks or 21 weeks based on the corresponding the crop condition or the crop type. In the 20-week process, some weeks the data will be sowing state will be there. Then it will be just creating some blooms. Then it will be going for the next level. Like that, it will be going on. In each level, what is the climatic condition? Each level, what will be the other parameters that is associated with the crop? These are all very much important. The level by level, the comparison or level by level, the relationship should be also important. That is, first week to second week, what will be the relation? First week to third week, the relationship between the climatic parameter. First week to fourth week, the relationship between the these are all the climatic parameter. Relationship will be important. Based on that, will be how to identify without increasing the size of the model. We have to identify the relationship between continuous week. For that, we focused on the temporal convolution, time-based convolution neural network for the yield prediction thing. Other than the vegetation parameter, here we had an advantage because we are using the hyperspectral images for the image analysis or for the crop analysis. We had an advantage. Hyperspectral images itself giving you some of the vegetation parameter, that is crop related parameter. Other than the climatic parameter, they will give you some insight on the vegetation parameters also. Therefore, we consider the vegetation parameters along with the climatic parameters. We designed a model. The prediction model we designed will be going for the vegetation and climatic data collection, and use the deep learning model for the model. There will be some, what are the vegetation parameter that will be associated with this? I am listing some of the vegetation parameters. Some of the faculties, they already known to this one. Some of them be new to this one. You can find the yield with remote sensing data also. How you can find how much photosynthesis is happening on that area. What will be the soil condition that you can find from the image? What is the wetting condition that you can find from the image? What will the irrigation part that you can find from the image? Initially, you will be discussing the same thing in some other experiments or some other classes or some other projects. People are wondering how we can find the photosynthetic rate from an image. Yes, it's possible. You can find the photosynthetic rate from an image. That image should be hyperspectral image. You can use how much greenness in an image. That is not considering what is the green pixel value. It is not considering the green pixel value. How much healthy the image. What will be the water index in that image. Everything you can find from the hyperspectral images. This work is going on. We are working in line with the ISRO SAC Ahmedabad. This work is in line with their project. They already have the set of images. Based on that, you will be calculating. We'll be just introducing some of the vegetation parameters. NDVI, this is the common vegetation parameter that is used for the yield analysis or the greenness analysis or the health analysis. Normalized difference vegetation index that will be calculating using the near infrared reflectance and the red reflectance. Using this equation, you can find it will be. But the problem this these NDVs that will be mainly affecting the climatic parameters, atmospheric effect, cloud, and based on that, the value will be difference. From that, will be introducing the new parameter that is enhanced vegetation parameter that is using along with the near infrared and infrared that will be using red band, R band and blue band for calculating the vegetation parameter that is enhanced one, and the two band extended vegetation index parameter that is the advanced form of EVI, and the leaf area index. These are all the important things that will be already using for the vegetation parameter. Some of the vegetation parameters only will be discussing. Whatever I used for my project, that only I'll be just listing out. Can just in detail you can calculate the NDWI, water index you can calculate, and the photosynthetic rate you can calculate, and this irrigation project that will be you can calculate. You can calculate the fertilizer other what will be the chemical content, everything you can calculate from the remote sensing images. You can use that whatever the data that will be useful for your project, that you can use for this one for the prediction purpose. These are all the main indices I used for my prediction purpose. The NDVI, EVI, EVI2, leaf area index, how much the leaf. Based on the leaf area, you can find that how much photosynthesis is happening on that shrub or that plant. That based on the photosynthetic rate, you can find how much yield it will produce after 5 weeks or 6 weeks. That is the based on that you can find this one. That what will be how much biomass is converted into the ecosystem, that you can calculate using those primary production. These are all some of the vegetation parameter we used for our project. Now we will be having our hyperspectral images. From the image you find that each pixel what type of crop it will be, classification you done. In the each pixel you can find the vegetation indices parameters also. Then we gone for the vegetation indices parameter and the climatic parameter. We designed a model, that TCN based model, the temporal convolution based model. This paper is also available. You can go in detail. We just giving the glance how will be working and how that model design look like. Be different TCN temporal convolution block, that will be 4 week difference we will be using. First week to fourth week, what will be the difference? Second week to fifth week, what will be the difference? Like that, it will be 4 week design pattern we designed for the TCN model, and we calculated the yield using this TCN model, that predicted yield value. That was the project. For that, which area we focused on? Our study region was, I am basically from Kerala. My study region was the Upper Kuttanadu region. That is the, you will be saying that the rice bowl of Kerala. That is completely focusing on the paddy field. We focused on the paddy field and we'll be getting the hyperspectral images from that one. We first gone for the classification technique, and we will be calculating all the vegetation parameter from the hyperspectral images. You will be getting all the vegetation parameter from this MODIS data, is the multispectral data. Then you collected the climatic parameter and the previous year yield for each of the state and the corresponding city or the corresponding village area. Everything will be available in the Government Agricultural Corporation of India. That website, it will be available. Some content will be paid one, you have to pay and use. Some content will be freely available and you can use this one. And based on that, we find the climatic parameter, we find the vegetation parameter and the previous year yield. Based on the TCN model, we designed this one. This was the result we focused on this work. There will be proposed model. We will be getting the minimum the error value will be more focus on whatever the work was done in 2020, end of 2020, the summer paddy region will be finding the success story that it will be almost equal to that of the actual predicted result. The yield result was that will be the error rate was very less. This paper is also available. Will be already published paper. Will be temporal convolution based crop yield prediction using multispectral data. This was the first work I done for the agricultural technology based on India AI's in line with the India AI yield prediction for the rice crop yield. That was the first work we done. You can extend this work in different dimension. If those who are new to this area, if you get a glimpse on what is going on this one, you can extend this on different dimension. different type of dimension you can extend. The major dimension now we are focusing on will be you collected the data of the climatic parameters, you collected the data from this website. This will be giving what will be the climate on each day when from the sowing state to the harvesting state. Each day we will be getting the climatic parameter. It won't be that much exact the value. It will be giving the value in that particular village. It will be giving the not giving the proper value. Now we'll be considering the climatic parameter. It is not deep in the ward by ward. The climate is will be different. In first 10 kilometer apart, rain will be there, and after 10 kilometer the same time rain won't be there. That type of climatic variation is going on, therefore it won't be that much correct. We discussed this work in the Kerala government itself. The first suggestion we got is that the climatic parameter what will be, even though you'll be getting very good result, the climatic parameter won't be that much good. It won't be that much accurate. How we can improve this one? The first thing we done for that one. Now the work is going on in this area that you can use some set of sensors. IoT based sensors you can use. You can place the sensors in the corresponding land and you can collect the information for the climatic parameters. Other than this, the vegetation parameter that you calculated from the hyperspectral images or along with the hyperspectral images, you can place, here I am not using any value related to the soil data. You have to find what is the rate of nitrogen, phosphorus, and potassium in the soil. How you can use that one, how you can collect the data. For that also, you can place some of the sensors in the field itself. That will give more accurate result or more number of parameters that is more closer to the your yield estimation. These are all the directions you can focus on your work. You just took an area, or now in some universities this work is going on. If will be your the department from the you'll be having from different department or different universities, you already focusing on this area. Some university already focus, they're having their own land. Even your I'm not that much aware about your university, whether you'll be having any agricultural department or something along combined with the agricultural department, you can go for this work. You can use this work and you can use the AI technique or the deep learning technique or the machine learning techniques for the early prediction along with whatever the data you are collected from the field. You can use some sensors, you can use the unmanned that aerial vehicles, UAV you can use to get the data. These are all the new things that will be, some of the things are already going on. You can design your own method. What will be the government is focusing on? If you'll be discussing with the government authorities or some of the departments, what they'll be focusing on, you are designing most of the papers, you will be creating paper, you will be publishing paper. That is not the mandatory thing. The mandatory thing is whatever you are designed, okay, you are designing this prediction model, that should be reached to the layman, that should be reached to the farmer. You have to give the insight to the farmer in early days. That is the motto. You have to focus on the design of a product other than a paper. That should be your focus. Then you can apply for some patent works and all. Will be good, and you will be going for the product base. Definitely you will be keeping this work is going on the agricultural field. That is the next level thing you can go for this way, and you can focus on the sensor based data collection along with the remote sensing data. You can go for the sensor based data collection. And another advantage or the next level we can focus on this one. Here will be now the current work I am doing along with this hyperspectral images. We already having a paper published on in conference. Now the under work of that paper that is published or that is already presented in one conference, along with this hyperspectral or the remote sensing data, you can club different modalities of data, other type of data, the Google Earth image you can use, or any other type. So will be, this is completely based on the spectral images, hyperspectral images. You can combine the SAR images, synthetic aperture radar image, different modality of data you can combine, and you can collect the information, or you can go for the classification technique that will be giving better result than this one. This work is already done in 2020. Now the new modalities, how to combine the different modality that work is going on, you can focus on that type of area. If you are new to this area, or if you're already working, or if you have to start working on this area, these are all the major levels you can explore. Either you can go for the sensor based data collection and you can clearly predict the yield. You can give this as a project combined with the agricultural department or any other agricultural university. You can use this one because based on their result value you have to calculate. Then the next one is you have to focus on the multimodality data. For the classification technique or the image data analysis, you can go for the multimodality data. That is another advantage. You can go for that direction. Multimodality data based crop yield area crop area classification, and based on that yield prediction. These are all you can focus on. Now you'll be going on this. You'll be finding that this MODIS data itself, the 1 pixel is 500 meter. The aerial resolution is 500 meter. That is 1 pixel itself be covering 500 meter. That is not that much good. You have to use the resolution will be very high. That is within 1 meter you will be getting the information that will be that much correct for the classification thing or the yield prediction thing. That will be better. That type of things you can focus on. Now the ISRO itself having the high resolution, 1 meter resolution cartosat image is there. SAR images, new type of SAR images they will be having. If you are collaborating the work with ISRO, you can use that type of data for the yield prediction. That will be an added or new direction for you. These are all the main things we already focused and we'll be continually working on that. You can also start working on this type of images. This is the first work we already in line with the agricultural technology of India A we focused on. We'll be having any doubt on this area, we can discuss. Otherwise, I'll go to the next work and finally we'll discuss the part. Over to the participants. Will be having any suggestions or it will be any things from my side I have to improve.
I request the participants to ask questions. Ma'am, we have one participant off the hand.
Okay.
Morning, madam. This is
Hi, sir.
May I know what are the different algorithms that are used especially for these agricultural problems?
Yield prediction, sir.
In prediction of the crop as well as so what exactly is the algorithm that suits different kinds of agricultural crops?
Yes, sir, that crop area estimation or the classification technique, this the deep learning model we designed. Sir, it's clear.
Okay, madam.
Yes, this model we designed. This I will share this presentation. This the model itself is available in this paper. It's already published work. Used the deep learning model. This work is started in 2019. That time the usage of 3D CNN convolution, 3D convolution network, multispectral convolution network, that was very rare. Now I think based on this, my paper itself will be suggested more than 100. Will be cited by more than 100 for the same related work. You can focus on this type of technique. Are now that lightweight attention models and the lightweight neural network, these are all and attention models, attention neural network, these are all you can use for in your future work. You have to go for this classification technique. You can use that type of methodology, sir, for the classification. And now the work is going on along with this hyperspectral images. You can go for different modalities, combine the SAR images along with the hyperspectral images, or combine any other Google Earth itself image itself along with the SAR images or along with the hyperspectral images. That will be giving multimodality images, will be giving more insight on this one. That is also another new direction of area. Now the work is going on that. I also working in that area, multimodality data analysis for the classifications.
Thank you, ma'am. We have one more participant.
Okay.
Good morning, ma'am.
Good morning, sir.
Could you please tell us which software you have used to get the spectral analysis data?
The survey, this work is already combined with this ISRO the Satellite Application Center, Ahmedabad. From that, we already atmospherically corrected data along with this vegetation parameter. We already got the vegetation. The work is like that. The combined work along with the ISRO. Like if you have to work on that, you can approach them, and they'll be calling for the ISRO that respond basket project also. This time also they'll be more focusing on agricultural things. You can work on that. Then they will be give you sample type of data. You can work on that. So like that we worked. This completely our work is in line with the ISRO SAC.
So, ma'am, I should write to ISRO to help.
Yes, sir. You can first create one login in this their Bowen website and their NRSC website. Otherwise, the best thing you can focus on the IARS Dehradun is there. There's a number of faculties are working on this one. You can write a letter for them, what are the work they are doing. They will be give you some sample data and you have to give some insight on that. If they will be impressed on that, you can continue on that. Like that also we are currently working, sir. That will be good for you. The start.
Yes, ma'am. So we have a plot in a place called Rajahmundry in Andhra Pradesh.
Okay.
So could I get the same spectral data for the same for the land that
Yeah.
we have?
Yes, sir. Yes, sir. You have to request for some land area. It will be free for a particular period of time. If you have to focus on suppose 2010 to 16 or 17, some of will be freely available. But you have to focus on the current scenario, the current years. You have to approach them. Then some amount should be there. But if you will be from along with your student having some consideration, and like that you can approach the faculty members, those who are working on that. They will direct you, sir. Like that only I also started.
Okay.
Thank you, sir. Thank you.
Hello, ma'am. There's one
Nice.
query from the chat.
Nice.
How are images collected for inferences? What is the frequency of data collection for inference?
The data will be already having that every NG website will be having a project that is associated with ISRO SAC. From that only, from there only will be atmospherically corrected data be given. We'll be working on that data. We'll more focus on more details on the data. Will be that it's already there in the present the papers itself. You can focus on the website also. I linked some data at the websites here. You can use that one for the more details because that work is still going on. I'll be just giving you a glance on that.
Thank you, ma'am. There's one more query from Tom C. William. Ma'am, is the multimodality data can involve data other than images?
Yes, you can involve other than images. You can involve multimodality data also. Other than images, you can use. You'll be getting, but there should be some normalization constraints in that. That you have to focus on. Therefore, yeah, I'm saying that if you'll be focusing on such type of work, you should have an expert from the agricultural field. Agricultural field, you should have an expert. Then only you can focus on that. That you have to focus.
Ma'am, and there was one more request from Amuda, ma'am, asking to share the paper DOI. So that
yes, I will share this presentation, sir. Ma'am, at the end of this one, you can use this.
Yeah, and also one more query from Shabina Bhaskar. Can you share the details of publicly available data set in this area?
Yes, that also I will share. Along with this one presentation at the end, I will share all these things and I'll give to the coordinators. You can collect from the coordinators.
Thank you, ma'am. I hope you can continue the session.
Okay.
Thank you, ma'am. Thank you, participants.
This is the another small work. Actually, it's not that big work because the data that we are collected is very limited. That is the tea leaf disease image recognition, disease recognition and detection system. The work I started actually in the starting of my PhD. It was in 2018 I started this work. The first focus is on this type of RGB images. Then only we currently shifted because my guide is already having a contact on this ISRO Slack. We'll have some discussion with that one, and my institution, parent institution, has also helped me a lot because they'll be already having the ISRO regional research center. Then we had a combined work. We had a discussion. Then that based on that only we completely shifted to remote sensing data. Now I will be reused this type of data and what I collected for my that we will be saying that the coursework will be for going for your research. Before that, you have to complete some credit. For that, I started this work, T-leaf disease area recognition. That you will be now. I'll be focusing on this thing also. That another direction of the agricultural technology will be leaf cap. That is a capsule network based disease recognition system we designed. It is already published in one book as a book chapter. Now the work is again going on because we have to use more data, the availability of data. Initially, I started the work, the availability was very less. We went and we collected the data from Nilgiris already. Now the UT region, from that is completely cultivation is the tea crop was the cultivation. We collected the data from that and we started the work. Then with the publicly available data, now I think after 2020, we get to know so many public available tea leaf disease data is available. We worked on that and we designed a model. Here also you can give, this is a just new method that we used for the disease recognition system. Is this also come back and there will be a deep learning based. We no need to work on only the deep learning or image technique or all these things. You can completely work on the data analysis part also. So many works are going on because my area from the BTech, MTech onwards, MTech specialization was also on image processing. From that onwards, I am continuously going on that area. That's why I'll just giving a glimpse on the precision agriculture in the remote sensing part or the image processing related part. You can completely focus on data related part also, that is no issue. You go through the website, India AI website, you will get to know so many things are happening on this area, and you can go through the website and you can find new problems and you can think about that. You can go for the new directions. Definitely you can achieve that. I'm sure on that. If your work is in line with the government vision, definitely you can go for the very good result. And that way, along with your colleagues or along with your students, you can go for that type of data. And this is the, it will giving a glimpse on how we'll be working. These are all the 8 type of 5 to 10 types of diseases we focused on that. Or will be different type of diseases. Will be collected the data from the Nilgiris. Will be limited data only we collected because the availability that the time we visited, that will be not that much good. Will be getting more healthy images other than the spreaded area or like that will be. Then we focused on the already existing data sets that will be already designed. This is the designed architecture. For this also I'll share the paper link. You can download that. Be just giving a glance on how will be going on the cap. That is we will already know those who are new to this one. It will be capsule network. That is small neural network design. The group of small neural network design other than a big the enlarged network will be going for the small neural network design. It will be more focus, more work on that. You will be getting the better result. And along with that, we will introduce some dynamic grouping technique in the neural network. Before going to this one, we'll be using a transfer learning technique that will be focusing on the VGG network. This was the leaf gap that we designed as leaf area detection or the leaf disease detection using capsule network. The different capsules will be using and different capsule network. Using the n number of capsule network, we will be finding that which the disease, which type of disease it was. This is the constructive network we designed. It will be based on, we worked our data based on the manually collected data and the corresponding already existing, the T-sickness data set is already existing. The augmentation we done on that data and we worked on this one. And these are all the data, this is class data split. We'll be using training, test and validation, 600 each. And 120 for the manually, only 120 data, 3 type of images, 3 type of disease images were there. This is the technique. The comparison that will be done out. The proposed model is working, will be compared with all other techniques. That was will be. Hello.
Ma'am, you can continue, ma'am.
Okay. that will be leaf area disease classification techniques that will be completely based on the disease classification techniques. So the proposed model, we worked on both the T sickness data set and the manually collected data. Is the that will be based on this paper also. You can go through this paper. You came to know what is the use of this. And not going to in that detail of the architecture, because will be just giving the idea that these are all the work we will be doing. You can go for this type of work, not explaining what is capsule, what is primary neural network, what is the DDR dynamic routing and all. You can focus on that. If you're working on that area, you can focus on this type of network. And here also you can lightweight neural network, you can liquid neural network you can use, and the different attention networks you can use. You can update this one based on the different type of architecture. This is the will be came to know that the model is working better before going to a type of BGG or the transfer learning technique. You can focus on this type of work and you find that this is the result. Now, this is the main two work we mainly focusing on the agricultural based technology. First work is completely related to my research area. If we need more explanation, I will share that. You can will be getting your thesis also. I think it will be openly available from NITK in National Institute of Technology Karnataka website, or the Shodh also. You can search for the thesis. Thesis also you can. Otherwise, I need the link also. I will add the link and I'll send the presentation. The second work is a small work. We had limited data, but if you are focusing on any other type of disease images or pandas, this is completely recognition techniques or the classification of the leaf based on the diseases. We use the that capsule network data and the image and that network for this data classification, and the use of dynamic routing and all already discussing in the paper. You can focus on that. This is the result they will be focusing on. This is the main two techniques that is already we discussed or that we designed for the other work that is in line with this agriculture. Along with that, you can go for so many other things. Now, what will be the future of AI? The future of AI in the precision agriculture now will be focusing on some of the will be a consortium of different countries. They will be having more focus on the drastic changes in the agricultural field or drastic change in the what will be the weather condition, how it will be affecting the agricultural region. These are all will be coming picture. Therefore, along with that, we will be going for the IoT in agriculture. That is the main focus on current days. Will be IoT will be based on the V6 architecture. Other than V4, they'll be going for the V6 architecture. Will be IoT is coming to the picture. Now you can use the IoT sensors for all this type of experiment what I discussed so far, and along with any other things also. Other than this prediction or other than this disease detection, you can go for any of the application here, that irrigation system. You can place some IoT sensors or sensors inside that. You can collect the data. Now you can available the data is available. You can use the data and you can put in directly the data from sensors, IoT devices. It will be going to the cloud. There itself you will be using some algorithm or some AI technique. You can give the result, and based on the results or insight what you will be finding, from that you will be collecting, they will be giving the insight, whatever you will be occurred or the decision that will be maintained, that will be directly give to the user, end user. That type of techniques are some projects are already there. Some of them be already came to know this one, some of them will be new to this one. Will be already some projects are already some application, mobile applications are available. The farmer can register on that application, and based on their what they will be placing some IoT devices in the field itself will be collecting the data, and the model itself, the cloud itself will be running some model and will be giving the insight. The similar to that of will be getting SMS, the farmer will get the SMS that this is the condition, you have to start irrigation, or you have to go for the next fertilizer cycle is starting, the fertilizer application you have to start. These are all will be going on, similar to some messages or some warning will be giving. The climatic condition is worst, going to the worst condition, you have to go for more irrigation part. These are all the other than this disease detection and yield prediction, you can use this IoT for any one of this technique, or that will be a new area, not a new area, that will be, you can also start the work on that type of area in the precision agriculture in line with the India AI concept or the vision. That is one thing you can go for the other. The futuristic thing that is be somewhat okay, you can water management. The sprinkler will be working without any human intervention. The sprinkler will be working. It will be fine. The sensor will be placing in the field itself. From the field, it will be calculating what is the water index. That water index value will be going to the corresponding cloud. From the IoT, it will be going to the cloud. Cloud, in the cloud itself, you will be having a model. Model will be run on that, and you will be finding the decision that this is the trees are in stress mode. They need more water. Then that information will directly pass to the sprinkler. The sprinkler will automatically work. That is the water management system. And soil monitoring sensor, you can find the value for the nitrogen, phosphorus, potassium, all these contents you can find. From that, you can go for that can give a warning to the farmer that the next cycle of fertilizer is needed. This much amount of the nutrients are less in the soil. That type of information you can get. That type of this IoT sensors and all that is not been that much costlier also. You can use that in a some small region. And what are the values? One thing you have to keep, if you be designing some model blankly or directly with some automatic techniques or some AI technique, you can't go for this model design and all. You should need an expert from the agricultural field. They only know for this type of yield, this much nitrogen is needed, this much phosphorus is needed, this much potassium is needed. That expert things you should know. Based on that only you can go for that. That is very much important. That is another. Machines for routine operation. If weeds are there, okay, I find that this area in the cultivation land, more weeds are there, you have to go for the weed cleaning. You have to give some information to the tractor, automatic machines, or you have to give the information to the corresponding person also, that you can go for. And now the era is on unmanned UAV, unmanned aerial vehicle, drones you are using, and you are collecting the data from the corresponding crop land. That is very, but the problem in this usage of drones is in some countries will be combined collaborative works will be going on based on the now DST and I think Taiwan NSTC some call. I don't know whether the date is over or not. Taiwan NSTC and the SSO, ICSSR, Indian Council of Social Science Research. They will be having a call along with the Taiwan NSTC. Your project should be related to this, the social science impact you should have. You can use the AI technique on social science impact. You can focus on this agricultural technique. You should have a collaborator in Taiwan. You just search for that. You can find some people and you can combine the collaboration work with this one. But you'll be focusing on some this type of collaboration with other country. If you are focusing on drone-based image monitoring or drone-based field monitoring, you should know the criteria that based on some security alert, some countries are not allowing drones. In India, we are not allowing drones in some regions because of security issues. But some countries, they will be not allowing drones in large region or a complete the land area or the complete cultivation land area. These are all the criteria you should know. That based on that only you can focus. This is the one project you can focus on ICSSR.
But I think you are frequently doing all this thing, right?
Hello.
Weekends. For culturals also, you run the game and dance, right?
fine, no? This is the one thing, that is the security part thing you have to focus on. If you'll be working on any unmanned vehicle things, you have to focus on based on the country's security issues. You can, the ICSSR project will be very less amount compared to DST or Servo or something like that. The project will be on very less amount, less than 5 lakh or 6 lakh or up to maximum 10 lakh project only. Within 1 or 1.5 year will be the time period. You can focus on that type of projects also. Those who are working or wish to work on some related, that the social science related or the society related things, you can club with AI. You can focus on such type of projects. That is one advantage you can use. You focus on that, that will be better for your the improvement in the research area. Then you can combine with some, and the collaboration will be working into the picturing more. That will be very important. You have to work on that. Previously people have an idea that, yeah, if I did the work, I will write the paper, the full contribution from the my side, I am the primary author of the paper. Some people are not ready to leave their code also. They're not ready to publish their code also. These are all the bad culture that they followed. Now the trend is in different way. You should have a collaboration with other country. You should have a collaboration with other universities, other faculty members. Then only your research group will improve. That should be your focus, should be on that type. Therefore, IoT in agriculture is the one future or the current trend. Or you can, other than whatever I discussed so far, you can go for the IoT based thing. The another one I discussed so far is remote sensing data fusion. Different type of data you can use. Optical remote sensing data, radar data, in the site itself data. You combining different type of data, you can go for the yield prediction, agricultural things. These are all the next level of projects you can go for the future. The future remote sensing data, different type of fusion you can use for. And the last one that will be focusing on the smart farming tools. Without any human intervention, you can directly design a tool that will be produce a smart farming technique. This best example will be plucking the tea leaf based on their health. That will be based on whatever the data that is available, that the sensor, it will be taking some images. That will be, more that find the images, analysis the image, and based on that they'll be saying that, yes, this leaf is very healthy, therefore I can convert that into tea powder. Then it will be going for picking, the plucking things and all. These type of sensors completely without human intervention, these type of projects you can focus. That is your focus should be more on the tools, or focus should be more on the product oriented things other than just papers. You can convert that into patents. That is the best thing you can go for. Other than papers, you can convert. Normally people will do whatever you will be writing before going to the patent. You will write as a sample paper and you will be published. That is the main thing, and you will be applied for the patent. That is, before anyone applying for this one, you should assure that this is your work. Like that you can focus. Your focus should be always on tools other than simple paper or simple methods or models. This type of smart techniques we can go for. This is the future in the AI technique. These are all one or two glimpses that I am giving to you. You may having more idea on this one. Maybe some of them are already working on this area. You should have any other idea. If whatever I'm thinking, those who are new to this one or are wish to work on this one, if I give a few insight on you people in the last 1.5 hour, then I'll be happy for that one. Thank you. That happy learning. If you have any doubt or anything related to this one, I'll share the presentation and what are the codes, my GitHub link, everything I'll share to the corresponding coordinators. It'll be any queries or anything related to this one. Just I'm giving some idea what I done or what I am doing. I think in some way I'll be giving some insight to you people. If at least 1% it's help you, I'll be happy.
Thank you, ma'am. Now the platform is open for question and answers. Participants, if you have any queries, kindly post your queries. Any queries from the participants? And there's a question from Thompson Williams. Ma'am, can you suggest any research funding agencies regarding this area?
Then if will be more focusing on the remote sensing area part, then it will be your focus should be on the ISRO response basket, and along with that, if there will be the idea what I'll be shared to my students or those who are my colleagues also. You will be using so much time in either Facebook or Instagram or any other social media platform. Similarly, the best way you can, if you are focusing on that type of things, you can more focus on X, that is Twitter. You should have an account if you are a research scholar or if you are a faculty member or whatever. This is my suggestion. Maybe it will be wrong in based on your concept, but what I feel is that you'll be having a Twitter account. You have to follow some of the person, those who are working in the same area. Every minute or every day, you will be getting, you just take a 10 minutes time. And other than you are using your other social media things, you just take 10 minutes time. You go through their website and those who are following their pages. Every minute you will be getting updates on that one. What are the things that will be working on with different countries in the same area, and the research that call itself. I will be saying the ICSSR and Taiwan's call. The call maybe started in March 1st. The information that you'll be getting to know from other faculty member or the university maybe in the March 2 or March 2nd or March 3rd or March 2nd week. But if you'll be focusing on this, or you'll be following all these type of research the consortiums or the people who those who are working on that, immediately you will be getting the response that this call is started, the end date is this one, this person is working on this one. And those who are focusing on postdoctoral things also, you have to be to be touching with some of the labs, those who are working on the same area. That will be good. Then you'll be getting to know what is the status currently going on this that type of research lab, or type of work they will be doing, where they will be lagging, everything they will be sharing in that. So similar to that of you are using your WhatsApp or any other social media platform, it will be a good practice. Those who are not yet started, you start, you follow this people, those who are working in this area. First, you know, maybe 1 or 2%. Once I started this one, I know only because my work is, I focused on the remote sensing data and the deep learning. And initially, I was started my work on MATLAB. Then the only one following thing I will be having MathWorks. And the another one is, you know, the author of this deep learning using Python, Francis Scholet. I just follow Francis Scholet. Then he will retweet the content from some other person. Then I came to know, okay, this person is also working on the same area. Then if I follow this person, I will get to know the another thing. Like that, those who are, you will be getting the suggestion that this is your friend's friend, or like that you will be add a friend. Similarly, you can go for the practice. You really should be focusing on that type of area of research work, then it will be very good for it. That is one thing. And along with this, all the research, the consortium of the research funding agency, they will be also having an account in this one, Twitter. And they will be having that some principal investigator, those who are working on that one, they will be also having the some lab that will be working on this one. They'll also, then you came to know this one. It will be only mostly focusing on the ISRO related things. You follow IARS, Indian Institute of Remote Sensing, Dehradun. You can contact the faculties there. And the second one is you can go for the ISRO response basket. Every year they will be creating the response basket, the research project. From that, you can approach the some of the, there will be principal investigator name will be mentioned there. You can directly contact them through mail or their phone number. They will initial status is they will give you sample data. You have to give the insight, then only they will proceed. Like that, you can follow. And these are all the things you can follow if you have to go for this type of research, or you have to continue along with your teaching career. But now the trend is that 50-50 teaching and research should be in the balanced way.
Thank you, ma'am. There's a feedback from the participants and all the presentation was really absolutely good. They're all happy for that, for the informative session. Now, yes, now the time.
अगर क्लासेस में अगर बच्चे कुछ कर सके, अभी इंटर्नशिप पे फोकस करना है कि सर वो पहले हैकफेस्ट पे करना है,
I request the
जो
participants.
उसी में है ना?
Okay.
It's the question for me. Oh,
No, ma'am, it was some outside talk. I'm sorry.
okay.
Yeah.
I thought they'll be asking for some internship related things to me.
Videos, so that we can have a group photo. Ma'am, please stop.
Yes. Presentation I'll do.
Yeah. And I request all the offline participants also to join towards the screen so that we can have a group here. Everybody, please stay online. We are calling the offline participants also to join. Thank you, participants. But once again, stay back. We would like to give the certificate of appreciation to our resource person today. Just stay online. Thank you for this, ma'am.
Thank you so much.
Department of AI, Andhra University. The copy will be mailed to you, ma'am.
Okay.
Once again, I extend our heartfelt gratitude to Dr. Alka Mohan ma'am for her insightful and enlightening session on the role of AI in precision agriculture. Her expertise and passion for the subject have truly enriched our understanding of this topic. Her comprehensive analysis and practical insights have provided us with valuable perspective on various topics such as PSM-based crop yield prediction, soil condition, photosynthesis rate, and weather predictions. And also on the topic one, a capsule, network-based leaf disease recognition, and also IoT related agricultural projects, the sensors for sprinkling the water on the crops, and drones for field monitoring, remote sensing, data fusion, and also letting us know how to kind of progress for smart farming tools. And also we have innovated various applications whereby researchers can work such as yield prediction, soil monitoring, detecting diseases and pests, automatic grading and harvesting, surveillance and security. Actually, all these days we were knowing about surveillance and security with respect to agriculture. This is a new topic now, wherein blockchain technology also can be incorporated. So it's a new insight for us. I take this privilege on the Department of AI for thanking you, ma'am, and also express a sincere appreciation for your valuable contribution to our faculty development program. Your session has undoubtedly left a lasting impact on learning journey. We are excited to continue our collaboration with you in future explore the intersection of AI and agriculture. Your insights have inspired us, and we look forward to leverage your expertise to strengthen the faculty fraternity at the Artificial Intelligence Department of Andhra University. Thank you, one and all, for the wonderful session, and I thank all the participants for joining the session. A small announcement. I request the participants to fill the feedback that will be shared in your WhatsApp group. And also I request the participants to join back sharply around 2 o'clock. Thank you, one and all. Have a good day. Thank you, ma'am.
Thank you so much. Thank you for the university and the Department of A and all the participants. It was a live session. What I feel is that it's normally the FDP, the faculty will be having some doubt on asking question. Somewhere will be like that. Why we have to ask students only ask? No, that itself will be different. They have some, if I will be at the 1.5 hour, or if we'll be giving only 1% of insight to you people to the new area, will be helpful for you. You'll be so happy. Once again, I'll thank the university and all the participants for the nice, there'll be the participation along with me. That's thank you so much.
The informative session. That's the reason all the participants told us not to, leave out from their chairs, ma'am. It was 127 above participants were there online.
Yes. Thank you so
Very
much.
effective one, ma'am. Thank you. Thanks a lot, ma'am. Bye-bye. Take care.
Thanks.
Signing off, all the participants kindly join around 2 p.m. sharply.